This lesson is really about factoring complex trinomials. The problem type is a times x squared plus b times x plus c. A, b, and c are numbers, and we are not able this time to factor out a GCF that lets us have no coefficient of the x squared term. Therefore, this one's going to be a little bit more complicated when we factor. However, when we set the signs, it's exactly the same way. We look at the second operation. If it's positive, it tells us to use the first operation for both signs. If the second operation is negative, it tells us to use one of each sign for our binomial pairs. So that hasn't changed. The next thing is the factor statement. It doesn't really tell us it really doesn't change either. We would say, and here's a problem that we're going to look at in just a minute, is example 1, 25x squared minus 20x plus 4. And I look for a GCF always, but I don't find it. So I know I've got the hard type of trinomial to factor. My factor statement, I said it the same way. Second operation, it says add, equal the coefficient of the b term, so we'll have to add to equal 20. I still want to also factor my x squared and set my signs the same, so I'll go ahead and set the signs. The plus tells me to use the first sign, so they're both going to be negative. And then I'll factor that x squared. However, I'm leaving room in front of it because this time there will be a coefficient in front of the x squared term. Now, step 4 is really where I want you to pay attention because it does get a little different. This time I have to factor A and factor and reverse factor C. So I'm going to figure out what A is. Remember, it's A, B, and C for my terms. A is the coefficient of the x squared, or 25, and C is what it's always been, the last term, which is 4. Now, factors of 25 are not too hard. That's a big number, but it's not too hard with factoring. 1 times 25 is the first one I would think of, and then 5 times 5, and there aren't any more. 4, I've got to think of the factors, and then I'm going to have to reverse them. I say 1 times 4, and I'll say 2 times 2. Now, I need to reverse these factors just so I'll have every possible instance, every possible combination of factors. But I don't have to reverse the A factors. Just reversing the 4 factors, or the C factors, will do it for me. So I'll reverse them. I don't have to write 2 and 2 to 2 times 2 again because it's the same frontwards and backwards. But I do want to write 1 times 4 backwards. So that's 4 times 1. Now we're going to look for combinations. Multiplication is what we're going to be doing. I'm going to multiply inside the factors that are sitting here next to each other, and I'm also going to multiply outside. That's why I'm drawing these arrows, insides and outsides. I'm looking for products, multiplying products that will add together to equal 20. So let's take my first example. Combination is 1 times 25 and 1 times 4. Inside, 25 times 1 gives me 25. Adding that to, remember, adds in my factor statement, 4 times 1, those are the outside. That does not add to equal 20, does it? So this one doesn't work. Let's try the next combination. I'll try 125 with 2. Inside, 2 times 25 is 50. Outside, 2 times 1 is 2. Well, that does not add together to give me 20. So the next combination, I would try 125 with 1. Well, 4 times 25 is 100. This is getting worse instead of better. Plus 1 times 1 is 1. Well, that didn't work. So this 125 combination I can cross off my list. It's not going to help me. Let's see what happens with 5. I'll try 5 and the first combination, 1, 4. So I would say inside would be 5 times 1. That's 5. Plus outside, 4 times 5 is 20. That's still not going to equal 20, is it? That would be 25. The next combination, 5 times 2. Is going to give me 10, plus outside 5 times 2 gives me 10. I like that one. It works. Here's the factors I use to get there. Now, where do I place them? The A factors always go in the first positions. In other words, the A factors go right here, right in front of my X term. So I'll put them in the same order they're in, 5 and 5. Although they're both the same, so it really doesn't matter, does it? And the C factors go in the second positions. So the C factors, always going to go right here. That's going to be 2 times 2. Now, I need to FOIL it to check, although I'm pretty sure it's right because both of the signs are negative, so I don't have to worry about the positive and negative being in the wrong place. But I say 5x times 5x is 25x squared. Negative 2 times negative 2 is positive 4. Then I do inside. negative 10x, and outside, negative 10x. When I combine those, I do get a negative 20x. And it's correctly factored. Now look, this one was sort of a simple one. There was a shortcut to doing this one, but I used it because I wanted you to be able to see how to do the complex factoring, how to use the system to do the complex factoring, okay? What we could have looked at is looked at this problem and said the first number is a perfect square. I'm going to take the square root and use it in the first positions. So I used 5x and 5x. The last number was also a perfect square, so I'll take the square root of that and put it in the last positions, 2 and 2. I have to still FOIL it to check because it might not add up to be the middle position. But if it's a perfect square trinomial, it will. This one was, but I wanted to teach you the system so that you can use it on numbers that are trinomials that are not perfect square trinomials. But if you remember the perfect square trinomial shortcut, you can do that and bypass some work for yourself. Let's try some other examples, and if you want to try these on your own and then just listen back into the tape to check yourself, you can. Example number 2 is another complicated trinomial. No greatest common factor is going to help us out. So, what we're going to look at is setting our factor statement. It says subtract to equal 27, and then let's set our signs. The negative in the second position tells us to use one of each sign. And then I want to factor my variables that are squared. So I'll factor the x squared into x times x. Now, I would love for this to be a perfect square at the beginning, a perfect square at the end, so I could shortcut, but it's not. 20 and 8 are not perfect squares. So I'm going to have to factor a, which is 20, and c, which is 8. And I'll come up with factors. It's always easier if you start with 1 times whatever the number is, and then you move your way up. 2 times, if it's an even number, 2 times 10, and then try 3, it doesn't, but 4 does, 4 times 5. And I don't have any other numbers that would go into 20. And remember, I don't have to reverse the A factors, only the C factors. 1 times 8 is easy. 2 times 4, those are the only factors of 8. So let's write them down in reverse order also. Now, draw arrows if it helps you to remember that you're going to multiply the inside terms and you're going to multiply the outside terms. You're going to see if they will subtract this time to equal 27, so keep your factor statement in mind. First, I'll try 120 and 18. Inside, 20 times 1, and then I have 8 times 1. There's no way that subtracts to equal 27. Next one, I'll try 120 and 24. 2 times 20 is the inside, so that's 40. 4 times 1 is the outside, that's 4. That didn't work. The next one I'll try is 120 and 4, 2. 4 times 20 is 80. 2 times 1 is 2. It's getting worse, and as I see these numbers are getting bigger, I know that it's not going to work. I don't really even have to multiply them. I can say 20 times 8, it's too big. So, but it is 160. So I know that 120 combination didn't work. As you get better at this, you'll start trying the middle combination first, because generally speaking, it's going to be either middle or somewhere in the middle ranges that we're going to find our combinations that work. But these didn't work. I'm going to cross them out. And let's look at 210. 210 compared to 18. 10 times 1 is 10. 8 times 2 is 16. That doesn't subtract to give me 27. 2 times the next combination. 10 times 2 is 20. 2 times 4 is 8. Still doesn't subtract to equal 27. The next, 10 times 4 is 40. 2 times 2 is 4. Not working. And the next one I know is probably going to be even worse. 10 times 8 is 80. 2 times 1 is 2. So the 210, I can cross it out. All right, the workspace that I need is still over here. I'm going to start with the 4-5 combination. You sometimes want to hold your fingers on it. I'm going to have to draw lines so you can see what I'm working with. 5 times 1 is 5. And 8 times 4 is 32. Does that subtract to give me 27? Well, hang on. I've got to think about it. 32 minus 5 would be 27. That's the combination I need. What did I use? 1 and 8, 4 and 5. Okay, remember where to put the A factors. First positions is where my A factors go, right? So A factors are going in the first positions, 4 and 5. And my C factors go in the second positions, and keep them in the same order, because the reason they work is because of their order, okay? 1 and 8. Now, because I have one of each sign in this one, I have to carefully FOIL. I might have to reverse the signs. First positions, I say 4x times 5x, 20x squared. Last, 1 times -8, -8. And like we said before, those are almost always right. Let's do inside. We have 1 times 5x gives us 5x. 4x times -8, -32x. When I combine those, I have a -27x, and the sign is not right. I need it to be a positive 27x. So I'll switch the signs around, make the first one negative, make the second one positive, and I'll refoil that middle section. -1 times 5x, -5x. 4x times 8, positive 32. When I combine, I get a positive 27x, and that's what I need. Let's take a look at example number 3, and we're doing the exact same thing. A complicated trinomial, we cannot do a GCF that gets rid of that first coefficient, so we're stuck with it. Factor statement, add to equal 17. Remember, add is the second operation, 17 is the coefficient of the middle term. Now let's set the signs. The second operation is positive, which tells us look at the first one. The first operation is positive, we use it for both. Let's factor, next in step 3, let's factor the variables that are squared. Well, x squared is the only squared variable we have, x times x. And then let's write down in step 4 what we're going to factor. A is 2 and C is 10. Well, 2 is easy, 1 times 2. 10, 1 times 10, 2 times 5, and remember we also have to reverse the factors for C. 5 times 2, 10 times 1. Now, draw arrows. You're going to multiply inside, and you're going to multiply outside terms, or factors, and you're going to try to see something that adds to equal 17. The first combination, 2 times 1 is 2, 10 times 1 is 10, that doesn't equal 17. The next one, 2 times 2 is 4, 5 times 1 is 5, still doesn't equal 17. The third one, 2 times 5 is 10, 2 times 1 is 2, nope. And the fourth one, 2 times 10 is 20, 1 times 1 is 1. Nothing equals 17. So, first we think we must have made a mistake. We look and make sure we copied the problem down right, and then we check our factoring and see if we did it correctly. If everything is right, you have tried every possible combination for factoring that trinomial. The trinomial doesn't factor. Therefore, we say the trinomial is prime. It will not factor. Let's do 2 more examples with factoring complicated trinomials. And in this example of number 4, remember that your first step in factoring any problem is always to factor out the greatest common factor. This one does have greatest common factor because all 3 coefficients are even. So I know I can factor out at least a 2. And 2 is the greatest number that will come out of 6, 2, and 60. Now I'm going to look at my variables, x squared, x, and no x term. So x squared is stuck. I can't factor out any x's. But I have y squared, and y squared in all 3 of them. Let's factor that out. At least we're not dealing with those terms. We're not dealing with a 2 and a y and a y squared. What does the trinomial factor into? Well, 2y squared times 3x squared would give me my first term. 2y squared times a negative x would give me my second term. And 2y squared times a negative 30 would give me my third term. Now I want to check that always. Make sure I've factored out the GCF correctly, because that would be a bad place to make a mistake. And just because the rest of the problem would be a waste of time. All right, my factor statement is next. I'm going to look at the second operation. It's subtract to equal the middle term coefficient, which is 2. Let's set the signs for the factor pairs. I'll create my factor pairs. I'm going to look at the second operation. It's a negative. Use one of each sign. I'm also going to remember to write down that GCF that I factored out, because it's an important first factor in this thing. Now, factor the x squared, and let's see what I have to factor. I have to factor a, which is 3, and 30, which is c, or c, which is 30. A just factors into 1 times 3. Well, that was easy. 30, however, is quite involved. 1 times 30, and 2 times 15, and 3 times 10, and 5 times 6, I think that's it. And now I have to reverse all of those. Okay, well, let's just write them down and hope we don't need them. I'll just start with 5 and 6, reverse that. 10 and 3, 15 and 2, and 30 and 1. Well, every combination is written. Just in case the thing is prime, I'll be able to tell right away. Now, let's compare. I'm going to multiply inside and outside terms. 3 and 1 gives me 3, and 30 and 1 gives me a 30. So 3 and 30 does not subtract to equal 2, so that one didn't work. Let's do the second combination. 3 times 2 is 6, and 15 times 1 is 15. Those can't subtract to equal 2, so that doesn't work. Let's try the next one. This one, 3 times 3 is 9, and 10 times 1 is 10. That will subtract to equal 1. So these are the numbers I want. Look at all the combinations that I did not have to try. It's okay. It didn't take us long to write it down. It was less than 15 seconds. So what do I use? A positions, I use a 1 and a 3. Now remember, I don't have to put a 1 when it's a coefficient of x, do I? It's understood. And for second positions, I'm going to use a 3 and a 10. Now let's check it. X times 3x would give me my 3x squared. 3 times negative 10 would give me my negative 30. Now let's do 3 times 3x to get a 9x. And negative 10 times x will give me a negative 10x. When I combine those, I end up with a negative 1x, and that is what I need. So the signs are in the right place, and I've correctly factored it. Just remember, you also have a third factor here. You've got the GCF, 2y squared, times the second factor, x plus 3, times the third factor, 3x minus 10. Okay, example 5. It looks fairly simple, but we have to remember that it has a negative in front of the first term, and your first step is always going to be factor out the negative. So when we factor out the negative or the negative one first, remember it changes the sign of every term that we put inside parentheses. So we'll have a positive x squared, a negative 24x, and a negative 25. Now we're ready to factor and set your factor statement. The second operation, subtract to equal 24. And we're going to set the signs, remembering that GCF, in effect, is really a negative 1. And I'm just going to put a negative because you know a negative and a negative 1 are the same thing when it's multiplied times something. The second operation is negative, so it says use one of each sign. Whoops, one of each. And then we're going to factor the x squared term, x times x. Now, I'm looking at this and saying, what do I need to factor? I don't really have a complex trinomial. There's no coefficient. So I'm going back to my old type of factoring. I don't have to factor a reverse factor c. I just have to factor c, or 25. 1 times 25, and there I found my solution. 1 times 25 subtracts to equal 24, right? So I will use 1 and 25 in these numbers, in these positions. And then I need to FOIL it. X times x gives me x squared. 1 times negative 25, negative 25. Inside, positive 1x. Outside, negative 25x. When I combine them, I have a negative 24x. And that is the term I needed. So don't forget, your third factor here is a negative, or a negative 1 times x plus 1 times x minus 25.